Today we are going to see water conservation through managed aquifer recharge. So what is artificial recharge? Then we learn about managed aquifer recharge. So artificial recharge or MAR, we can call managed aquifer recharge as MAR. Both are used to improve the groundwater potential of the aquifer. So artificial recharge means in this rainwater is the only source we can consider. Previously, we were doing only artificial recharge. Rainwater is used to artificially recharge the aquifer because whenever it is raining, automatically, naturally, the rainwater is infiltrating, percolating, and it is recharging the aquifer. When we go for artificial recharge, we intentionally catch some of the rainfall from the runoff and then we are recharging it. That is artificial recharge. Then, what is managed aquifer recharge? In managed aquifer recharge, the water of different quality can be used to recharge the aquifer. So what are the different quality or different type of water which is used for managed aquifer recharge? The different type of water includes rainwater, tertiary treated water, or water in the river, or desalinated water. Any water can be used for the recharge. So when we say different quality, the rainwater will have one quality, tertiary treated wastewater have different quality. That is what we are telling here. So water resource manager can decide the water to be used for recharge and corresponding recharge structure. Here even we can decide the particular recharge structure to be used for particular type of water. In case we are going to use only rainwater, we can choose certain type of MAR structure. If we are going to use tertiary treated water, then we have one more type. We are going to see what are the various type of MAR structure and what water is used for the recharge we will be learning. And here it is given water, water resource managers can decide the water to be used for recharge and corresponding recharge structure with the controlled management. What is that controlled management here? We have to continuously check the quality of water before recharging and after the recharge. So it is not just like that naturally recharging. Then treatment before the recharge. What kind of treatment we are going to do with the water? So that is a controlled management. Then continuous monitoring of aquifer response because we are going to use different quality. When it is getting recharged, how the aquifer is going to respond to that water, how the quality, ambient water quality is getting changed. All these things should be continuously monitored when you go for managed aquifer recharge. Sometimes during managed aquifer recharge, natural treatment is also expected to occur because when we use the tertiary treated water, it is not fully treated. It is a kind of partially treated only. But when we use that water for recharging purpose, when it is passing below the ground, passing through the pores, the natural treatment is further taking place. Okay. Now, let us see what is the importance of this artificial recharge or managed aquifer recharge. Why only rainwater is not sufficient? Rainwater recharge is not sufficient for us. Okay, let us see now. When we see the global water resources, let us understand the global water availability. So if you just consider it as 100%, 97%, we have too much of water, but it is in the ocean. Why don't we use the water in the ocean when it is available? We'll not have talk about water scarcity, but we need to use. Why don't we use the ocean water? Because it contains too much of salinity. The treatment cost is very high. It is not economically feasible for all the countries, and all over the globe we cannot have the ocean water. Even if you want to use that, even we treat, then again transportation, many issues are there. So that is why it is difficult for us to use the ocean water. Then we have 2.2 percentage of glacier water, which is very fresh water. But if you see, it is in the form of ice. So even this water cannot be readily used by us. So if you see, almost 97 plus 2, 99 percentage of global water is not directly usable by us. Okay, we can use only 0.7 percentage of groundwater and which is available, and only the surface water which is available, fresh water which can be readily usable by us is less than 0.1 percentage in most of the area, whether it is developed or developing country. Even this water is contaminated, so we cannot directly use the river water. If it is in a remote area, the water is very clean. But if you consider even India as an example, 70 percentage of untreated wastewater is led into this river water. So we cannot make use of this water also. This situation making us to go for artificial recharge. Whenever there is a rainfall, most of the water is going as a runoff. Some part of it we are trying to recharge using the structures, because the natural recharge is not sufficient because of the industrial development, agricultural development, as well as increasing in population. The water which is naturally recharged is not sufficient. The groundwater is the only available large quantity of fresh water on the earth. So we are trying to increase that groundwater. Okay, that is why we are going for managed aquifer recharge. Apart from this, we can tell n number of reasons why we need managed aquifer recharge or artificial recharge. We will just consider India as one of the example, and what are the issues of the India in India with regard to water resources, how this MAR or artificial recharges can help to improve the Indian water resources. Okay, so need for water conservation in India. So likewise, we can take any country and we can see it may have different type of crisis. Okay, so now let us look for India. When we first see the geology of India, we have seen the global water resources. Groundwater is the most available fresh water for us. But for that, the aquifer should be capable of storing more water into it. But if we see the geology of the India, 70 percentage of the land area in India is hard rock. They are not very much capable to store the rainwater. Only 25 percentage of the Indian geology is alluvium, which is very much capable of storing groundwater. This itself necessitates the need for artificial recharge or managed aquifer recharge in India. Whereas, other than that, when you see the rainfall pattern of India, almost average annual rainfall in India varies 300 to 650, and sometimes it goes up to 800 also. It is actually sufficient amount of rainfall, but what matters? It is not spatially distributed, as well as temporal variation is also very high. The rainfall is not uniform. During January, February, March, April, May, the rainfall is very less. Whereas June, July, August, September, October, almost most of the rainfall is falling during this period, and again most other period there is no rainfall. So the rainfall is not uniform. So whenever it is raining, we need to manage the water. We need artificial recharge or managed aquifer recharge. So this rainfall pattern also clearly tells that India needs more water conservation methodology. Next. And then, if you see India, it is an agrarian country, agricultural country, and 80% of its irrigation depends on groundwater only. Because in southern part of India, we have only non-perennial rivers. Whereas in the northern India, we have perennial rivers where they can take water from the river. In the northern parts, they can take the water from the river and they can use it. But still, the infrastructure for the agriculture is poorly developed. Even the canals or the transporting system is not 100% ensuring us that water is reaching the irrigation agricultural land. In such a case, they depend on the groundwater even in the northern part of the India. Whereas in the southern part, as the rivers are non-perennial, sometimes they go for rain-fed crop. During all other season, they depend only on the groundwater for irrigation purpose. This over-dependency on groundwater causes groundwater level decline, and it also causes groundwater issues in India. This also emphasizes the need for managed aquifer recharge. Okay, so whatever with this hard rock region or with this non-uniform rainfall or more amount of groundwater, is only we have less amount of water. Is this water is good for drinking purpose? Let us use the available water directly for irrigation industry or drinking. Is that possible? If you see, we have another crisis. Almost 96 districts in 12 states have been affected by high arsenic contamination in groundwater, and fluoride waste reported in 230 districts of 20 states of India. So we know the arsenic and fluoride. You can see when we go for arsenic, it causes skin cancers, whereas when you go for fluoride, dental fluorosis or skeletal fluorosis, the bone is getting affected. So people cannot even use the water which is naturally getting recharged. This is the another issue in India. Then further, if we see the coastal region, salinity in coastal aquifer, almost the entire southern part of India, is covered by coastal region, coastal aquifers only. Because of the heavy population and then more development near the coastal region, and then patterns are happening here, this causes the saltwater intrusion into the land. So the fresh groundwater which is available in the land, because of the over pumping and high population in India, the groundwater is also getting affected. Then sometimes the natural disaster, sometimes most of the time in the northern India, heavy flooding, whereas in southern part or sometimes in the northern part, we are experiencing flood and drought. Okay. And finally, is this quality of water, let it be fluoride, let it be arsenic, is it easily available to the people? No, this is also sometimes not available easily. Women walk a long, they spend their time, and sometimes the tankers which are supplying fresh quality of water, too many people are surrounding. And during night time only, the water, sometimes the lorries are allowed during the night time with the fresh water. People are not even sleeping to get this quality of water. All this again emphasize the need for artificial recharge or managed aquifer recharge. Whatever scenario we are seeing, some of this may exist in any other water starving countries. Now, beyond all everything, the climatic change is also giving a more stress in India. 40% of the Indians will face water scarcity by 2050. So this is what given. That too, because what is going to happen, what is expected is, as per Indian Meteorological Department, you can see that the Indian annual mean precipitation trend is projected to increase. Because of this, there may be flooding in India. And also, if you see, more rainfall is expected in the southern part of the India more than the northern part. And apart from this, the southwestern part of India, compared to the rainfall, 20% of the increase is expected in southwest coastal part compared to the rainfall which occurred between 1850 to 1900. This is what expected in this area. Rising temperature and precipitation can increase the occurrence of glacial lake outburst, floods and landslides over dammed lakes. These are projected because of the climatic change. Both Ganges and Brahmaputra river basin will also see increased flooding as a result of climatic change, particularly if warming is increased over 1.5 degree, the glacial melt. Because in southern part, if you see, because of the climatic change, more rainfall is expected in southern part of the India, whereas in northern part of India, where these river Brahmaputra, Ganges are flowing, because of the temperature increase, the glacier melt will be there. They may release more amount of runoff into the northern part of the year. So entire India, we may expect high amount of flooding, and sometimes there may not be rainfall for a longer period, which may cause drought also. So India is expected to see an increase in frequency and severity of hot extremes. Whenever it may rain, we are expecting more amount of flooding, or sometimes extreme hot climate is also expected. So all these situation in one country, for example, what we have seen, it is a hard rock area, rainfall is not uniform, and this is an agrarian country where more amount of water is required from the groundwater, where the recharge is very much essential. And the water quality which is available is also contaminated, not geogenically or coastal aquifer and climate also. All these things we can slightly manage. That's all. Completely the artificial recharge or managed aquifer recharge is not the solution to solve all these issues. But management to some extent is possible through artificial recharge and managed aquifer recharge. Is it not happening in India so far? Because one example I consider it as India, so I'm just giving. When we see in India, there were traditional technique which were used from north to south. Zinc, Naula, Boyali, Pat, Dabri, Urani, Eri. There are many ancient rainwater harvesting system. But these systems, slowly due to the development, urbanization, these systems were failed, actually speaking. Then If you see, even from 3,000 years ago to 35 years ago, there were a number of studies were also carried out in India. What kind of recharge structure, olden type of recharge structures that were taken place. Every kings, they were trying to develop more number of water conservation structures in India, even before the improvement or more level of population generation in this country. Agar, Surangans, Uranis, Eri, Jallara, Eri and Kulams, Kadin, Talabs, five example five. See here, 3,000 year ago, again 2093, had 400 years ago, step wells, 362 years ago, Kohli tanks 242 years ago, bamboo method of rainwater harvesting 200 years ago, Talai 100 years ago, Johar 38 years ago. So there are n number of recharge structures where already recharging methods were already existing, but they vanished due to the urbanization or modern construction. They have not incorporated into their system. So now these are some of the widely practiced MAR methods all over the world. So far we have seen some of the example why managed aquifer recharge is essential. One country is considered as a um, example to highlight what are the crises that can occur and how this MAR can be helpful. And now let us see what are the widely practiced MAR methods and where it is useful, what water quality, everything we will see. So, aquifer storage and recovery, aquifer storage, transfer and recovery, percolation pond, riverbank filtration, soil aquifer treatment, rainwater harvesting, farm ponds, check dams. These are the recently used methods all over the globe. They are using this. Now let us see aquifer storage and recovery. So here you have one injection well where you inject the water through this. And you have another well where you can pump out the water. In the aquifer, you are storing and recovering. Here we can use the same well for injection as well as the recovery. So creation of whatever the surface water it is available will allow that surface water to get into the ground. So creation of subsurface storage which is used during lean period. Storage is the main goal. We are not talking about any treatment when it is stored inside the ground. Treatment is smaller consideration. This can be used in confined as well as unconfined aquifer. We can go for rainwater or fully treated water can be used as a source of water, and even desalinated water can also be used. So now the next one is aquifer storage, transfer and recovery. Here what we are expecting is we are storing through one well. It is transported. It is just passing through these pores, through the impervious layer, and you have another well in the downstream side, and we are taking out the water. So this also can be used in confined and unconfined aquifer. So during the passage, when it is moving, we are expecting some natural treatment that may occur. Okay, we will see in the next slide, what are the treatment that may occur during the transport of water below the ground? So, if you see here, this is some example, world largest aquifer storage and recovery project in Dubai, completes stage 1 of construction works, where the desalinated water, treated desalinated water is put into the aquifer and they are recovered during lean period. This is some of the example. Now, we will see this is river bank filtration. Now we are going to see the river bank filtration concept. We will just see where the best explanation can be given with this slide. Yeah. So this is the river bank filtration scenario. Best suited for perennial rivers. Pre-treatment before recovery through bank filtration. And it is suitable for unconfined aquifer. And the source of water is river water. You can consider this as a river water. And through the river, water is passing through the pores and you have a well through which the water is coming out. During the passage through this aquifer sand, what will happen is the water is getting treated. Some of the impurities will be filtered. Maybe if you have some of the floating material, that floating material will be retained in the river itself, like leaves or some of the plastic material will be retained in the river. Only water will be passing through the pores. During its passage, adsorption. Some of the material will be absorbed in the soil particle. Sometimes there will be filtration process will take place. If there are any organic content in the river water, when it is passing through the soil, some of the microbes which are capable of decomposing the organic matter which is in the river, that will be decomposed by those microorganisms and we expect very good water when we are taking out the water from this well. This kind of recharge structure where it is widely practiced means in Germany, they even 100 years before, they were using this riverbank filtration for their water supply. If you see here, Germany, total 5 billion meter cube per year of water, almost 60 percentage of groundwater they are using. So bank filtrate water is 16 percentage. Sources used for drinking water protection. In Germany, 60 percentage of water is from the river water. You have a river and a series of bank filtrate recovery wells along river in Germany. These are the bank filtration wells. The river water will pass through the aquifer and during the passage, as I said, all the filtration, absorption, mechanical filtration, physical filtration, biological treatment, everything will be taking place through this aquifer system and we get the fresh water. If required, it can be chlorinated. We have to check the water after the after we pump out, then it can be used for water supply. This is one of the managed aquifer recharge structure, river bank filtration. Because when we put the river near, when we put the well near the river, the surface water, instead of recharging, the contribution from the surface water to the ground will be very high. When we pump, more amount of water with a high pressure will be reaching the pumping well. So indirectly we are recharging the surface water from the river. Now, percolation pond. It is best suited for unconfined aquifer. In a weathered portion, we can use this percolation pond. Even with the depth of minimum, it can be even 1 meter also enough depth. Depends the area, we can construct this. And see here, automatically wherever there is a percolation pond, it will be recharging. N number of percolation, wherever land is available, we can construct a percolation pond. It can be bigger in size also. Then soil aquifer and treatment. So we said managed aquifer recharge means even the treated wastewater can also be used as a source of water for recharge. If you see here, soil aquifer treatment, as I said before, the treated effluent is stored in this water. Even grey water also they are using through this method for the recharge as well as natural treatment. So in the infiltration pond to facilitate nutrient and pathogen removal in passage through unsaturated zone for recovery by wells after residential in an unconfined aquifer. So we have tertiary treated water and it is passing through dune sand with silt and clay. So water percolates down to the groundwater, becoming purified as it's travel through the soil. So that's why it is called soil aquifer treatment. So you have observation well. You can keep checking the water level rise or water quality. Everything can be checked and we can pump out the water through the recovery well. Here also further if necessary we can go for chlorination or any additional treatment. But almost all this filtration cost will be reduced when you go for this soil aquifer treatment. Then check dam. So this is a structure which is constructed across the river. So as I said, one condition in India where we have mostly non-perennial rivers in the southern part of the India. So only during rainfall the river will be flowing and maybe in southern part of India we can assume October, November, December is a rainy season, northwest monsoon where we get high amount of rainfall. If we do not have such structure, whatever rain is which is falling, everything will go into sea. But when you have a small recharge structure like a check dam, which is constructed across the river, this structure which you are seeing, the height is only 3 meter. They are constructed and the water can be stored. Only part of the runoff will be retained, harvested, and this may help to increase the groundwater recharge in that area. This is one of the MAR structure. So the collected water is used for groundwater recharge or sometimes directly the water is lifted from the check dam storage and used for irrigation purpose also. So this is one of the structure. So check dam is different from the major dams. Check dam mostly the height we can call up to 6 meter as a check dam. Beyond that it will be considered as a dam because it is a small structure. It is just arresting the flow of water, checks the flow of water. That's it. It's not a dam kind of 50 meter or more than 100 meter. It is not like that. It's a small structure. Sometimes the height may be even 1 meter also. Many number of small structures can be constructed across the river and we can harvest the water. Now, farm pond. It is constructed within the farm land. Even a minor farmer who is having a land less than 1 acre can also have this percolation pond. Here we can see the size is even 3 meter by 3 meter and depth is 1 meter. Major advantage of the farm pond is that every farmer can construct the pond. No much energy is required to pump the water. And it is mainly suitable for unconfined aquifer and the geology, irrespective of any geology, we can have. Even in the hard rock area also, if the top portion is weathered, very easily we can construct the farm pond and it may increase the groundwater quality and farmer can use this water for some time. And then because when every farmer, if they have a small pond, the entire basin surely will have, instead of having a big percolation pond, small pond in every piece of land will improve the groundwater recharge of that entire area. Here, the source of water can be rainwater, or sometimes even the agricultural return flow can also be conserved using this farm pond. The next thing is rooftop harvesting. The roof runoff is diverted into a well or a sump or a caisson filled with sand or gravel and allowed to percolate to the water table where it is collected by pumping from a well. So if you see here, whatever falling on the roof, that is collected and it goes to underground sump and it is recharging when taken from this well. That is what we are telling. And this is exclusively suitable for urban area. All over the place, whether urban or rural, we can go for it. But sometimes in urban area, everywhere we have pavements or concrete roads. Sometimes it is not possible for natural recharge, but in from the every roof, we need, it doesn't need any specific area for the recharge. Just a simple pipe with small pump, sump or caisson filled with the sand is enough. If they have a well directly, even rainwater can be sent to the well also. So if you just consider, in India, the Tamil Nadu is the first and the only state in India which has made rooftop rainwater harvesting structure compulsory to all the houses across the state. There are legal provision to punish the defaulters in case, if they do not have a proper rainwater harvesting system in Tamil Nadu. Sometimes they don't give a water supply, or sometimes the current supply or taxes may be high. These kind of actions are also taking place in Tamil Nadu. But this is the first state, they who passed the GO to make it mandatory that every house should have a rainwater harvesting system. Now, for a small calculation we can do, how this rooftop, how much volume of water can be stored using this rooftop harvesting system. It is not a rainwater, it is a rainwater harvesting system, but from the roof. Roof runoff is diverted into a well. So first what we need to do is, we need to take the area of the house. Rooftop area of the house should be considered, and annual average rainfall of the area and runoff coefficient for the built up land. Mostly we just consider as a flat concrete roof. In such a case, the runoff coefficient is 0.8. So the total volume of water harvested from the rooftop is area of the roof, runoff coefficient, and annual average rainfall of the particular year can be considered, and how much water can be stored. Now, let us see this problem practically. An academic institute has rooftop area of 58,000 meters square, and academic block is like that. And then 60,000 meter square men's hostel and 24,000 meter square women's hostel, with an average annual rainfall of 950 mm and a student population of 20,000. Calculate total volume of water that can be harvested via rooftop harvesting. So, total volume. So, what it is given is, let us use this pen. So this is the roof. Okay. So one roof is 58,000 meters square, another roof. So let us add all the roof area. So here 58,000 plus 60,000 plus 24,000. This will be our area. So the total area 58 is the total area. Even it can be individual. This is for the entire institute we are trying to calculate. So the formula here is area into runoff coefficient into annual average rainfall. So total volume is equal to area 1420 meter square into runoff coefficient. Here, the runoff coefficient for the building is 0.8 into annual average rainfall. It is given 950. Let us convert into meter. 950 meter. This is the so total volume is 920 meter cube. This is the total volume of water that can be stored. So this is first part is over. Now the second part what they are asking is the number of days the